All right, number 4, page 3 of the sample test of chapter 12. We have this state that has parties A and B, and in other words, what percentage of the state is in favor of A? Well, let's see, there's 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So there's 36. And A has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And 22 divided by 36 happens to be, I used my calculator, I divided those, and it multiplied by 100, and I got 61%. 61% favor A. That means 39% favor B. That's 14 out of 36. Okay. Gerrymander the state with 6 districts and 6 letters in each district in maximum favor of the least popular candidate. So B is the least popular. So I want to clump together A as much as possible. So got to have 6. So here's A with 6. Let's see. And can I get another A with 6? Oh, I look right here. And now I should be able to get B to win at some of these. Let's see how many I can. Let's see. In 6, I'm going to have 4 and 2. So 4 B's and 2 A's, 2 A's and 4 B's, 2 A's and 4 B's, 4 B's and 2 A's, 4 A's and 2 B's. So I could get B and B and B and an A and an A and an A. Looks like it'll be a split, 50-50 split. Okay. Show why this is the maximum gerrymandering for the least favored candidate. All right. So if I've got 22 A's and 14 B's, and I want B to win, B's got to have 4 to A's 2. So if I do 4 and 2 and 4 and 2, that's 12. So I only have 2 left. So B can't win anymore. And A will have the 4, and then it'll be 6 and 6 and 0 and 0. Or I can have 5 and 1 and 5 and 1. But B can only win 4. Win 3 districts with 4 2 margin. Okay. And then last page. Apportionment. Suppose 4 states are listed above, A, B, C, and D, and have these populations. And we're going to do 15 representatives. So we're supposed to distribute the 15 over this using the Hamiltonian method. So we're going to add up how many people there are. 5 and 15 is 20, 30, 35700 people divided by 15 representatives is 35700 divided by 15, and that's 2380. Did I do that right? I think so. So now I got to take, that's going to be my standard divisor, 2380 people for representative. Okay, so Hamiltonian method, I got to take each of these and divide by 2300. So 5,000 divided by 2380, and I get 2.1. 5700 divided by 2380, and I get 2.4, and then 10,000 divided by 2380, and I get 4.2, and then I do 15,000 divided by 2380, and I get 6.3. And so if I do the 2, 2, 4, and 6, I got 10, 14. That's not all of them. So then I have to choose the one with the highest here, and this one to get plus 1. So the distribution would be 2, 3, 4, 6 for A, B, C, and D. Does the Hamiltonian method have the Alabama paradox? Well, that's when you add a representative and a state loses some. Someone loses. So if we add a representative, that would make our standard divisor be not 2380, but 35700 divided by 16, which is, I'm now going to divide by 2231.25. And now how does it work? Let's see. So we take, putting it someplace where you can see it there. 5,000 divided by 2231, and I get 2.2. If I do 5700 divided by 2231, I get 2.55. If I have 10,000 divided by 2231, I get 4.4, 4.8, 4.5, and finally 15,000 divided by 2231, and I get 6.7. So that's still 2, 2, 4, 6, and I have, that makes a total of 14, but I'm trying to do 16, so I have to add 2. And so the highest ones would be here and here, and since nobody lost anyone, this is the one that gets the extra. There is no Alabama paradox. Nobody lost a vote, a representative, I should say. Okay, Jeffersonian. So now we're going to take these same numbers and we're going to decrease this to try to get all of them done. Well, we already decreased it to 2200 and it didn't use 15, it was only 14. So I need to decrease it more. So I'm going to take the original numbers and divide it by 2100. So I'm going to take 5,000 divided by 2100 and I get 2.3. I'm going to take the 5,700 divided by 2100 and I get 2.7. So that's still 2 and 2, so that hasn't picked up the 1 yet. Hopefully we'll get it here. 10,000 divided by 2100 and we get 4.7. So that's still 4. So maybe here we'll get it. Let's see. 15,000 divided by 2100 and that's 7.1. So 2247 doing the Jefferson. If I use the standard divisor of 2100. Okay? Does the Jefferson method give the same as the Hamiltonian? Nope. Jefferson gives 15th rep to D instead of to B. Nope. Jefferson gives the 15th representative, that extra one, to D instead of to B. Hamilton gave it to B. Jefferson gives it to D.